Today we're going to continue with section 4.1, exponential functions. Today we're going to evaluate functions with base e, and we're going to use compound interest formulas. All right, so the natural base e. So a couple of lessons ago, I first showed you where you could locate that number on your calculator, and I said that we were going to be talking more about it later. Well, today is the day. It is an irrational number. Okay, so once again, it's symbolized by the letter E, but it's a number. It's an irrational number. It appears as the base in many applied exponential functions. It's usually referred to as the natural base. Sometimes we call it Euler's number because that's the man that discovered it. It's defined by the value 1 plus 1 over n raised to the power of n as n approaches positive infinity. So approximately it's around the decimal 2.718281827. Okay, but remember, irrational means that it's just going to keep going and going without any particular pattern, or like it's not going to be a repeating decimal, just like the number pi. Okay, but it's approximately 2.718. Okay, so that's what this number represents, and we're going to be using it a lot, like I said, in some application problems. All right, let's talk about compound interest. Compound interest is interest computed on your original investment as well as on any accumulated interest. In general, when compound interest is paid n times a year, we say that there are n compounding periods per year. So let's talk about some of the vocab of what n could potentially be. Oh, I guess I'm ahead of myself. Let's talk about the formula first. So here's our formula for compound interest. So it says after t years, the balance A in an account with principal P, so principal being like your initial amount, and the annual rate R. So R is represented, though, as a decimal. It might be given to you as a percent, but you always have to convert it into a decimal. It's given by these two formulas. So anytime we have n compoundings per year, we use the formula A equals P times 1 plus R over n raised to the nt power. When we're talking about continuous compoundings, we say A equals P times E to the RT power. Now, these are two formulas that you are going to have to memorize, and you're going to need to know the difference. So anytime it says continuous, we're using what I call PERT, okay, that P times E to the RT. But when we're talking about n compoundings, so once again, I'll talk about what the n could be as far as vocab goes in a second. That's when we use that top equation. Okay, but we're going to have those two formulas memorized. So here we go. Compound interest. Anytime I use the word annually, remember annual means it's happening one time a year, so n equals 1. When we're talking about compounding semi-annually, think of like a semicircle. It takes two semicircles to make one whole circle. That's why n equals 2. When we have to compound quarterly, well, hopefully we think, oh, hey, there's 4 quarters in a dollar or 4 quarters in a year, because we have like 4 seasons in a year. So n equals 4. And then we have compound monthly. Well, n equals 12. There are 12 months in a year. Okay, so anytime we see those vocab words, these are the values for n that we are going to be thinking about. So let's dive into some examples. It says the sum of $10,000 is invested at an annual rate of 8%. We're going to find the balance of the account after 5 years, and it's going to be subject to these 3 things. First, we're going to compound it quarterly, then compound monthly, and then finally do continuous compounding. Okay, so let's identify a couple of things. From both of those formulas that I talked about, there are several variables that are always going to be the same in both. One of those is P, which is the principal amount or the initial amount. So notice how we're starting with $10,000. So that $10,000 is going to be represented for P. Another similar variable was R. R represented rate. Now notice that it says the annual rate of 8%, but like I defined it, I don't want a percent. We have to turn that percent into a decimal. So you either think about dividing it by 100 because it's out of 100%, or you move the decimal 2 places to the left, and either way, that would get us 0.08. The other variable that was common with both was t, and that is the amount of time. Here it says they want to know the balance of the account after 5 years. So those three things are similar in every single one of these three different problems that I'm asking us to do. Okay, it's just the compounding that is different, which then depends on what formula we use and what value for n we use, if that's the formula that we have to use. So remember, we've got the p times 1 plus r over n raised to the nt power, and then we have the PERT. The PERT formula. All right, so notice how in the first one it says quarterly. So that means that we know we have an n value. We have an n value of 4. So that means we're using this first formula right here. So I'm going to plug in my information, and this is what I want you to do on your homework. This is what I need you to do on a quiz and on the test. You are going to identify each of those variables with the numbers, and you're going to show me the setup that you use to plug into your calculator. Because if you just put something into your calculator and give me an answer without any work, I'm going to have absolutely zero idea where that number came from if it's incorrect. So show me how you are going to be typing it into your calculator. So I know that we're going to have 10,000. In parentheses, we'll have 1 plus. We'll have 0.08 being divided by 4, and that's being raised to 4 times 5. So that's what I want to see. And then you can go ahead and you can, actually put it into your calculator and get an answer. So because we're talking money, I do want us to round to obviously 2 decimal places. So this should have ended up being $14,859, and it looks like 47 cents. So if you are not getting that number in your calculator, please reach out to me because we need to figure out what you maybe did incorrect. Okay, but that should be your answer. In part B, we're talking about compounding monthly. So once again, we do have a value for n this time as well. N is 12. So once again, everything is the same except we're just swapping out 12 for 4 from that very first problem. So we still want the 10,000 because that's what we started with. We still want to have the 8%, so 0.08, but now I want to divide that by 12. And then I want to multiply the exponent 12 times 5. Okay, once again, it's money. We're rounding to the nearest cent. So that would give us $14,898.46. Okay, notice that this number is bigger than the compounded quarterly, and that should make sense because when we're talking about compounding, we're talking about building interest. Well, getting interest 12 times a year is going to give you more money than just getting interest 4 times a year. So the more that you compound, the more money you're going to be making. So it should make sense that we're getting bigger with each compounding amount. Notice that in part C, it says continuous compounding, which means that they don't have a vocab word that describes what n is, which is why we're then using the other formula. I want to use the formula with the number e. So p is still 10,000, but then we'll have e raised to the 0.08 because that was my rate times 5 because that's my time. So once again, don't forget that when you're trying to type in that number E, you want to hit the second button on your calculator and then the LN button. So that's how you find E on the calculator. We do want to round once again to the nearest cent. So it's going to end up being $14,918.25. Notice how this one is the biggest out of all three because continuous compounding means that the compoundings never stop. So it should be the biggest out of those three. Okay, let's take a look at another example. Okay, so it says, suppose you have $3,500 to invest. It's asking which investment yields the greater return over 9 years, 2.5% compounded monthly or 3% compounded continuously. So that means that we have two different situations that we're going to have to do both of them for, and then we're going to compare. But it says we have $3,500 to invest, so that is going to represent our P value. We're talking about a 9-year investment, so that's representing T. Remember, 2.5% is going to get us the rate, but we have to think about dividing that by 100 or moving the decimal 2 places to the left in order to actually get the decimal that we want for the problem. So if I move it 2 places to the left, it would be 0.025. And then when we're compounding monthly, that means that n equals 12. So I'm going to plug that information in for this. So we'll have 3,500 times 1 plus 0.025 divided by 12 being raised to the 12 times 9 power. Okay, so when I do that, it looks like rounding money to the nearest cent, we're going to get $4,382.10. All right, so there's that amount. Now we want to compare it to 3% compounded continuously. So 3% as my rate needs to be changed to a decimal. So I divide that by 100, move it 2 decimal places to the left. That would be 0.03. If we're compounding continuously, that means that we're using the PERT formula. So the P is still the same. We're talking about investing $3,500. But now I want it to be multiplied by E raised to the 0.03 times T, which is 9. All right, when I type all of that carefully into my calculator, we should get $4,584.88, I believe. Let me double check that. Oops. All right, so 3,500 times e to the 0.03 times 9 power. Yep. Okay. So obviously then now I have my two particular answers for both scenarios, which yields the greater return. So what gives us the most amount of money? It looks like this time it's going to be the 3% compounded continuously. All right, so once again, I showed my work for both of these. I showed what I was typing into my calculator before I came up with my answer. And that's what I expect you guys to do as well. So go ahead, pause the video, try to find these two scenarios here. We're talking about a sum of $5,125 being invested at a rate of 4.25%. After 2 years, what's the amounts compounded semi-annually and compounded continuously? All right, hopefully these are the values that you got. Remember, I had to change the 4.25% into a decimal, so 0.0425. When we're semi-annually, that's about n equaling 2. When we're continuous, that's when we're using the PERT formula with the number E. All right, so with those values, I rounded to the nearest cent because we're talking money. So hopefully that is okay with us evaluating with the function with the base of E and starting to understand those compound interest formulas.